Welcome to Module 3 video related to gear trains. So what's a gear train is when two or more gears are made to mesh with each other to transmit power from one shaft to another. Such a combination is called gear train or train of toothed wheel. So types of gear trains are simple gear train, compound gear train, reverted gear train and epicyclic gear train. In the simple gear train, distance between the two gear it is large, intermediate gear is employed. So here you can see one gear on each shaft gear it is attached. So here if the number of intermediate gears are odd, motion of both gear is like. If it is even, it is unlike. So here the velocity ratio of the gear train it is calculated by n1 by n2 is equal to t2 by t1. So the ratio of speed of the driven to the speed of the driver is known as the train value of the gear train. So n2 by n1 is equal to t1 by t2. So here speed ratio of gear 1 and 2 is n1 by n2 is equal to t2 by t1. So if you take gear 2 with respect to gear 3, it is n2 by n3 is equal to t2 3 by t2. So overall ratio if you take for the gear 1 to gear 3 is n1 by n3 is equal to t3 by t1. Like this you'll be able to compute. So speed ratio is the speed of the driver is equal to speed of the driven. That is equal to number of teeth on driver is equal to number of teeth on driver driven is equal to number of teeth on the driven divided by number of teeth on driver. So train value if you want to calculate, so it will be the same. The intermediate gears are known as the idle gears. They do not affect the speed ratio of the train value of the system. Idle gears are used to connect gears when large center distance is required. To obtain the desired direction of motion of the driven gear, clockwise or anti-clockwise, it is decided. When you take compound gear train, so you can see there are many gears which are connected to each other. So there are 6 gears which are connected to each other. So in the first there will be driver and the last which is driven it will be having a single gear. So in between those two there are 4 gears but 2 gears are connected to gear 1 and gear 6. So the gear ratio, the speed ratio when you calculate that is n1 by n6 is equal to n1 by n6 is equal to t6 by t5 you are supposed to take the ratio. So here you can combine or you can find it individually the speed ratio what is required in the compound gear train. So at last you can see n1 by n6 is equal to t2 into t4 into t6 divided by t1 into t3 into t5. So like this you will be able to take the speed ratio of the compound gear train. So here x is equal to the distance between the center of two shafts, n1 is equal to speed of the driver, t1 is equal to number of teeth on the driver, d1 is equal to pitch circle diameter, n2, t2 and d2 is equal to corresponding values for the driven, pc is equal to circular pitch. So like this you'll be able to calculate. So what are the advantages of compound gear train compared to the simple gear train? So there will be a large speed reduction from the first shaft to the last shaft, obtaining with small gears. In the simple gear, we used to get large speed reduction. Last gear will be able to take it will be a very large speed. So like this, there will be a difference between the simple and compound gear train. So further, if you take the reverted gear train, it is used in automatic transmission, lathe back gears, industrial speed reducers, and in clocks. So here there will be two. There will be two. One simple gear train, one simple gear, and another is a compound gear. So on the existing one there will be coaxial shaft with respect to the first driven, and the compound gear it will be connected to the second gear. So here the distance between the centers of the shaft of the gears 1 and gear 3 and 4 must be same, that is R1 plus of R2, that is equal to R3 plus of R4. So this is the condition what we can expect in the reverted gear drive. So T1 plus T2 is equal to T3 plus T4, the toss set must match. So when you take the speed ratio, N1 by N4 is equal to T1 into T4 divided by T1 into T3.